Hello and welcome. Today we're going to be looking at the Mercury Barometer, standard air pressure, and the Manometer. Before you continue with this, you must have watched the Ed puzzle assignment video before you continue this video. So if you haven't done that, stop, go to the Ed puzzle, and then you come back to this. So you finished the video explaining how the Mercury Barometer works. Okay, so we basically have a upside down tube that was filled with mercury. Okay, once it's turned upside down in the container, the mercury runs down and this becomes a vacuum. Okay, and what they've discovered is that at atmospheric pressure, 1 atmosphere, which is in IG physics we're going to use 100,000 Pascal. This distance there is 76 centimeters or 760 millimeters, and we call that 760 millimeters of mercury. Okay, and that is equal to 100,000 Pascal. Now that becomes an important ratio. Okay, so what happens is, if the air pressure, so we've got air pressure pushing down here, okay, so as the air pressure pushes here, this pushes up, okay. If there is less air pressure, okay, then this pushes down and this decreases. So if there's a drop in air pressure, the air pressure pushes less and this will drop less. So if at high air pressure the distance from this level to that level is bigger than 76 centimeters, and at low air pressure it's smaller than 76 centimeters. We will now look at standard atmospheric pressure. So we've said that standard atmospheric pressure is 100,000 kilopascal, okay, or 100 kilopascal. If you convert those 3 zeros into kilo, you get 100 kilopascal. Okay, in scientific scientific notation. So 100 kilopascal, where does that come from? So if we look at our Mercury Barometer, we've said that that level is 76 or 760 millimeters of mercury, and we know that pressure is density, gravity, height. Okay, so if we use the height there, 76 centimeters, 0.76 meters. Okay, so the density of mercury is 13,590 times 10 times 0.76, and that's going to give us, if we type it into our calculator, that gives us 103,284 Pascal, but in A level or IGCSE level we rounded off to 2 sig figs, and 2 sig figs would then be 100,000 Pascal. This is at sea level. Now if we go higher up, this decreases, and therefore at Mount Everest it's more difficult to breathe because there's less air, okay, less air pressure pushing down. At sea level, that's the highest air pressure that we can get. So now we will be looking at Mercury Barometer questions. In this question they want you to indicate which height would be used. So obviously we know from the level here to the level at the top. In this question over here, they tell you the atmospheric pressure decreases. Now, what's going to happen with the pressure inside the tube? Remember, that's a vacuum, so there's no pressure in there. And the level here, is the level going to increase or is the level going to decrease? We've discussed that before. And here, since you've watched the video of the Mercury Barometer, you can compare the different sizes in the tubes, whether it makes a difference, and the different levels here. And they're comparing day 1 with day 2. Two different barometers were used. Okay, so they were asking about the density or the atmospheric pressure at point X and Y and the pressure of the day. Now we will be looking at the manometer. So the manometer is a tube that we use to measure different gases. So in this one, the one side is always open, so that is the atmosphere, which is 100,000 Pascal pushing down there. And then we would have another gas here. So we put mercury in there, and the mercury level will always be the same if this is open as well. And we have the same atmospheric pressure here because this side and this side is equal. But if we connect it now to another gas, okay, and this gas pushes more, then we will have a lower level here and that level there. So here, if the gas is bigger than the atmospheric pressure, this is how it would look like. Okay, and if the gas's pressure is less than atmospheric pressure, it would look like this. So now, knowing that 76 centimeters or 760 millimeters is equal to 1 atmosphere or 100,000 Pascal, we can measure this distance in centimeters or millimeters and then convert to Pascal. So we can calculate the difference here. So if this is, let's say, 7.6, then it means that this one is 10% less than those two. Or if, well, let's use an easy amount. So let's say this distance is also 76. So that means that it's the 100,000 Pascal of the air, and that this is that amount less than, so this then is 0 over here because that distance is so much. Okay, so if the distance is the other way around, okay, so if this gas is bigger than that and this is, let's say, 40 centimeters, we convert the 40 centimeters to Pascal, and we can calculate the difference in the gases. So this one is 100, and that one will be the amount of pressure associated with that more. So we will calculate how much is 40 centimeters, how much pressure is that. If 76 is 100,000, 40, we calculate the pressure, we add it to the 100, and that will be the pressure on this side. Another variation of this is when they put a gas trapped in here, okay, instead of having a vacuum. Now, if it's higher than that, the gas's pressure is higher than atmospheric pressure. If it's the other way around, then it means that the atmospheric pressure is more than the gas. And using the same principle where we use ratios, we can calculate what is the difference in that, and by adding that or subtracting that to atmospheric pressure, we can calculate that amount of volume. Let's go look at a specific example. In this question over here, they give us a barometer telling us that 76 is 1 atmosphere, okay, and here we have a mercury barometer next to it, and we see that the trapped gas has got a 10 centimeters more pressure, okay, so 10 centimeters more pressure than the atmospheric pressure of the air. So here is air, and air has 100,000 Pascal, or we can say that the air has 76 centimeters of mercury, because this is what we see over here. So what we want to now do is, we know that this must be 10 centimeters more than the air. So the answer here is 76 plus 10, which gives us 86 centimeters of mercury. So just to repeat for those of you, they tell us that air pressure is 76. So this pressure here in mercury is equivalent to 76 centimeters. The difference between this one and that one is 10. So this pressure here must be 10 centimeters more than 76, which is 86. And remember, 86 centimeters of mercury can be related to Pascal as well, because we know that 76 represents 100,000. So 86 divided by 76 times with 100 will give me, if we look at that, would give me 113.157 Pascal. So that would be the pressure on the left, which is obviously not the question, but it's got to do with the difference in heights and how we can calculate the pressure of the other side. So this 10 centimeters is the difference. The air pressure is 76 centimeters. If we convert it to Pascal, it's 100,000. So this one has more than 100,000, and we can also alternatively just calculate what would be 10. What would be 10 centimeters? So if I say 10 divided by that, we see that the trapped gas has got 13,157 Pascal more than atmospheric pressure. So we can also calculate the difference using the 10.